Hello and welcome back. Today I have something special because I did something silly. For years and years I've been trying different multimeters. I started with 3.5, then go to 4.5, then 5.5, and in the end I tried a lot of 6.5, 6.5 digit multimeters. First I started with second hand, but soon I already find out that it is not always your best choice because it is a precision instrument, and if you want to measure precise, you preferably do new because of the calibration. But still, it can look very attractive to buy second hand because the price of course is a lot lower, and if you know it's from a good source or there are good pictures, you can take that risk. And I have been unlucky, but I also have been very lucky. For instance, with my GW Instax, it was almost not used and it was true, so I got that almost new even though it was second hand, but for a second hand price. Well, I don't do a lot of repairs myself, but I like to have a 6.5 digit multimeter just because I also like to play with references, just like I like to play with my frequency counters with the GPSDO. I like to do the same with the voltage, but I'm far not knowledgeable enough to really be a volt nut, but that doesn't mean I like a lot of digits. One of my favorite is absolutely the Keithley because of his fast scan speed, and they had that already here with the older one, the 199. I've tried some other models also, all with a brown theme, and here also later they changed to the white like the 2000 series. And later of course that is my first new meter, that is here the Keithley DMM7510. I love it, the speed is great. It has even graphics that is so fast it will blow you away. So the silly thing I did was, because my setup for the 6.5 is near perfect for me the way I use it, with the Keithley, the new Cyclant as well, and the GW Instax, it's a good setup and it is more than I need. So it's time for a 7.5. And here it is, it's the Keithley DMM7510, and I took a big risk with this. It came from eBay, from China. It is obviously used, it is dirty, and as I said, I took a big risk because even if the device is sort of good, all the functions work, you still maybe need to calculate in your price later that you want to have it calibrated, because what is the use of a 7.5 multimeter if you're not sure about the calibration? So it arrived, of course I couldn't wait, I switched it on immediately and it starts. Oh, look at that, all those digits. Ooh, so it seems to work. The only thing I noticed is that when I pushed the buttons, it was not working very well. Now it's very sensitive, but it had an old firmware, and when I pushed, I really need to push through it. So there was a problem with the touchscreen. So I did some quick test with my DMMcheckPlus just to see if is the readout, does the current work, AC, DC, resistors, capacitors, all seem to work. I checked again in my eBay and I had a money back guarantee if it was not working. On the item it said it was working, fully working. So, and it seems to be. So I can continue a little bit further and wanted to update the firmware. Updating the firmware is like really easy. You just go to the menu, info, update, and then here you select update to new or downgrade to older. With some version I updated from 1.3 I think all the way up to 1.7. You can do it in one step. I didn't read any problems with that. The only thing I needed to do is I needed to select downgrade to older, because it probably only looks to the last two digits if it's older or newer. So if you do big steps it will think it is older, and then I don't know if it has a file filter or not, but anyway, you need to read in the document that comes with your firmware if you need to select upgrade to new or downgrade to old. I needed to select old and I could jump immediately to 1716. So after that a reboot, and the touchscreen is super soft. Instead that I needed to push very hard, and that makes sense because if you are here you wanted to respond well. Still I need to clean a little bit, but look at this. This is just like your phone, it's so smooth, and it will work better later when I clean. Then I had something else that was a little bit weird. Every time I rebooted, it gave a message that it couldn't find a certain script. So I thought, okay, I need to find the factory reset somewhere, because maybe because of the big step in the firmware, some things don't align anymore with the old settings file or so. I couldn't really find the factory reset, but the thing that comes most close to it here is the system reset, it says, but it didn't solve my problem with the script, so I needed to look further. But then I realized reading that you could automate completely everything with this meter. So probably it was used in a test setup to verify certain electronic devices, and I go to scripts and I go to manage scripts, and this list was full, and there was also a script that was called AutoCal. So that's a script that it tries to start while booting, just like your old Dodge machine. So I removed all the scripts, rebooted, and that problem was solved. So that was also solved. We are still good. Then I wanted to use the AutoCal function. If the device goes to a complete different temperature, you can use this AutoCal function. It needs to be heated for at least 90 minutes, but also you cannot even use the function if you didn't do it. So that is smart. So to find that, you go again to the menu, calibration, and here we can see some information. Well, this is yesterday. I already did my AutoCal, and that was the third time I was done. So it was not done that many times. You can also see here that I cannot really do it because they advised me to wait more than 70 minutes. And you can schedule that also if you don't want to wait that long. You just walk away. And if we look at the factory calibration, I think that was done only the first time in the factory, because I see only count 1. So this is probably the state it left from the factory, because it will not be much older than a year or 10. I think between 8 and 10 years. So I started the AutoCal. This will take about 8 minutes. It's quite some time. Well, the device is clearly used, and I didn't pick the nicest one, of course, because I wanted to have the best price possible for a working unit. My Chinese is not that good, but I think it is 22 and 23, so it expired just a few years ago. Yeah, the rubber is used, the device is used. So I can clean this, of course. I don't see any damage on the display, but you can also see it's not necessarily that clear. So maybe I can clean that a little bit. It looks good, not too many bumps. A little bit dirty, but yeah, that is all to clean. And yes, it's older, so the rubber is a little bit soft, so it's easy to take that off as well. The warranty seal was, by the way, not broken. I was the one who did that. But we can look at the back here and we see it's very complete. We have the same terminals in the back as in the front. We can switch that over with one extra. In the back you can go up to 10 amps, while in the front you can only go up to 3 amps. And this extra connector that we have in the front is not 10 amps, but it is extra shielding. Here we have the LAN port, also LXI compatible, USB, this is digital I/O, this is not serial, and here we have the TSP link. So when you connect the device to the computer, you can link different Keithley devices with the TSP link, and then the computer only needs to be connected to the first meter, and then you just daisy chain them. We have IEEE 448, that is a GPIB. It comes default in this model, and that's usually an option. And here we have external trigger, if you like to use that. The fuses are huge, but it also has to do with the shielding on the inside. I found a very nice teardown on the EEV block, and SignalPod did a very nice hands-on video. I will link these also. Yeah, look at that, huge fuses. unlike the Keithley DMM7510, it doesn't have a voltage selector here. The other one had a linear power supply inside, and you needed to switch it over from 110, 130, or even 220, 230. This one is switch mode, and you can feed anything between 100 and 240, around 50, 60 Hz, it will take it. I already did some quick measurements downstairs, but I want to clean it first, then I put it in my stack, and when it is in the right position, it is heated to the right temperature, I will do again the AutoCal, and then we check again. So I washed these rubbers just in the sink, because rubber should not have a problem with water. So that's no problem. A little bit old school cleaning, no special LIPA, just dishwasher soap, and it is clean, a lot better. Look at that, like new. Now we can have a look if the inside is dirty or not. I'm not gonna do a real tear down, but we can have a little look inside without any problem. Here, the seal that was here, I broke, so the former owner did not do any silly things with it. That actually looks very clean inside, so I'm not gonna do too much. I measured the battery is still 3 volts, so that seems to be full. Yeah, this is mainly the communication board, I think. What we have here, oh, this is all closed. So this is all shielding plate, connected also to the fuse here. That is probably for the DC part, this one, because it goes up to the nano amps, I think. So every little distortion, even on your fuse, you will see. This is a little bit dusty. I see they put a ventilator here, so this is probably an after design, because you would expect to have it somewhere in the side and blowing out in the back, because now it needs a suction from probably, that is why. Probably it sucks the air out somewhere here, or blows it out there, and then it takes it here. So it is very little space for the air. So maybe that will make it a little bit noisy, but in the stack we maybe not here. We can have a little look underneath. Also looks very clean underneath, so it's only the fan that is a little bit dirty. Here we have that grounding ring for the current, and I think, if I remember, for the teardown, underneath here is the reference, and it is actually based on this Motorola, but it is a Fluken custom made thing. I will look if I can find some pictures for that. It doesn't have its own oven, so that's all underneath here. Well, I have some stuff here, and it is called the Tech Spray E-line, and I'm not sure it is still allowed to be sold, because I can't find it anymore in the Netherlands, but it could be a little bit aggressive, but it is great for multimeter fronts. Look at this. I think it's almost like new, because it had this little brownish glow, and now it's just super light gray, almost a white look again. Even the back looks quite new. Yeah, look at this. This is like new. I think I was kind of lucky that it was a little bit dirty, so it didn't look that good. So I got a real nice price. And now it's just like new. So yesterday I rearranged the whole stack. I did my little Tetris, took a few hours, but I needed to stop filming because it was getting around 32 degrees, and even the multimeter started to complain. Oh, the AutoCal was done around 25, and now it is 32. so you don't get accurate measurements. So I needed to stop. New day, let's have a look. Always nice when you start to rearrange, because then you also start to improve some of the cables. So a lot of the things got another position. I changed some devices, and I think also with the color scheme this fits nice. The correct devices are on top of each other. I think it is good like this. I will switch it off again and only use the devices now that we need, because I don't want the temperature again to get too high. Wow, and look at that. After the cleanup, it really made a huge difference. Even the rubber looks like new. You hardly see the difference here between the two, and you can see how sensitive now the touchscreen is. That is really great. A huge improvement. I was really scared a little bit about that. And here we see the difference. This one was sort of new, I think a year old, and this one is 9 or 10 years old. Now look at this. Cool. So what I like to do now is just do a test. How good is this 7.5 compared to my 6.5 GW Instack, compared to the 6.5 here and the Sigland. The only thing is, it is already above 25 degrees, and the longer I wait, the hotter it will be. This one did an AutoCal yesterday around 25 degrees. But they all need to heat still, so they need to heat to be stable, but then the temperature will be higher. So I will try to open some windows and at least wait an hour. I think it should be. Okay, the room is still around 25 degrees. I tried to measure all the 4 meters. I know we are not at 10 meg anymore. We are a little bit lower, but the Rytec here can deliver that power. I'm set to 1 volt. The Excel readout I don't mind too much. I just want to see the difference. As you can see, this one is almost 1 volt. It is just 2 counts. Here we are in 4 counts, but here it seems more, but it is a digit more. So here we are also around 4 counts, and this one is a little bit high. So at least I'm happy it's not super far off. I checked on the website for Tektronix. If I want to calibrate it factory with adjusting, it will, with cleanup and I do firmware updates, it will cost you around 600 euros, which is too much for me. I will not do that. It is within these counts, so we just going to see. If I go to 2 volts, here it is spot on. Here we have spot on. This one is also almost there, and here we are still a little off, but who will say which one is right? Because this one doesn't have AutoCal, this one doesn't have AutoCal, only this one has. So if we go a little bit higher, 3 volts. Also, it would be silly to expect it to be spot on, because this one, I think it's 25 ppm, so I think if we are on 1 volt, that would be about 25 microvolts, and this one is probably a little bit lower, so that would be, I don't know, I need to check, maybe 15 or 12, so that would be 12 microvolts, so 1, 2, 3, 1, so it is within specs if you think of it like that. Doing now a current measurement with the DMMcheckPlus. Let's see, this should be around 1 milliamp, but this is 99973, 9971, 99, almost 7. I can maybe set a filter that it doesn't jump too much. Let me see. And here we have, this one is actually, yeah, it's also 7. Look, 997. So I think these all agree. So that is nice. We can try the same on AC. Now we have here these two sort of agreeing, and this one is a little bit lower, and this one is also a little bit lower. So yeah, but that is these ppms that you are allowed to have some variations in this. And AC voltage here. This is from the DMMcheckPlus. I think it's around 100 Hz. And we see they sort of agree. This one agrees with this one. This one is slightly higher and this one is slightly lower. This is on 100 Hz, but we can also try this on 10K to see how they all respond. We see this one measures a little bit higher, this one goes a little bit lower, even lower, and now this and this one agrees. Let's try a simple 2-wire resistor. I have the DMMcheckPlus here. I'm looking in the specs, and this 1K resistor is 3 zeros and a 1, so pretty close. So let's see what the meters think of it. The temperature is rising already, also taking that to account. Also, I didn't zero the meter because we are measuring 1K, so below the ohms. Yeah, maybe I should zero it, but let's try without. So 1001 and a bit, so very close by. This one also 3 zeros. This one is practically a little high, but this is then below the ohm, so I should zero it probably. But if we do a rough measurement, this one is fractional high and this one is good, 001, perfect. Okay, let's try that also in a relative mode. Let me see, that all works different with each meter. So I set it to 0. What do we have now? Now it is actually slightly low. No, but this is 1K. No way, what? Yeah, this is 1K. So let's try the same here, but we already saw the meter is not crazy far out of spec. Look at that, how low it's measuring resistance. Oof. Relative. Yeah, let's try that again. Look at this. This is 10001. Look at that. Wow, 1K. And what about this one? No, again. Yep. Okay. Yeah. This one is still fractional high. Let me see how it does work in this one. Let's start with 1 nanofarad. Capacitors, this one is a bit high because the DMMcheckPlus scanned this one on 097. 98. This is fractional high. 97 is actually quite close for the cyclant. Let's go to 1 microfarad. And the 1 microfarad should be 1036. 1036, pretty close. A little bit higher also. This one also, and but they all think more or less the same, no? 006. This one was also 06. This one also 07. And the only way to know for sure is that I get this LCR meter, because maybe it was also 006. So maybe it was measured with a very high frequency, and these of course measure with a lower frequency. They all agree. Cool. I didn't do a 4-wire yet, and I want to try that. I have here these old calibration resistors. I'm of course not sure what the real value is, but we can just see if they agree or not. So I'll put them to relative mode to have the 4-wire exactly to 0. I have here this 10 ohms resistor connected it 4-wire. Temperature is a bit high, it's almost 28 degrees, so that will have some influence. But look at this, 10,000,74. So what does that do on the other meter? And the connectors really fit well, because it is, look at this, 10,000. We are here really in the micro ohms. Pretty cool. So the resistance measuring is pretty cool. Oof, they are a tight fit. This one is actually a little bit low. Okay, this is what it is. Look at that, the same 10,000. So pretty happy with my new burgers. They all seem to agree, so it's not far off out of calibration. And still, if you look at the accuracy, this one is 30 ppm, that one is 25, and this one I need to look up, I think it was 12 or 15. So even though they are all calibrated, you are allowed to have a slight difference, and I'm actually surprised how good it still is after 9 years. So very lucky, I took a risk, it arrived, and it is still good. Thank you for watching, I hope to see you next time.